setting out of points with orthogonal coordinates. Here is one drawing for representing how we organize the setting out drawings when we use orthogonal coordinates. So this method for laying out, it is realized from initial direction. So it is absolutely necessary to have initial direction. In this case, this is the red line, and this initial direction, it is always between two given points that usually are points from the survey network. In our case of setting out detailed development plan, these points are the certain line points. So we have our initial direction, and there is a point, for example point P, that is from the project that we want to set out. The setting out elements here, when the method is with orthogonal coordinates, the setting out elements are the coordinate differences delta x and delta y. These coordinate differences, they are in a local coordinate system where the direction x is the same as the direction of our initial direction AB, and the next direction of the coordinate differences y is the perpendicular direction to the initial one. So, for example, for point P, the new point, the setting out elements are firstly the distance delta xp, which is measured from point A to the end of the perpendicular line here. This length is the first setting out element, and after that the second one is the length of the perpendicular line. This is going to be delta y for point P. Why? Because when we use orthogonal coordinates, we need to draw a perpendicular line from each new point to the initial direction. It's gonna be absolutely the same if we have another point, for example point M. The first setting out element is going to be the distance from the starting point A to the end of the perpendicular line. This is going to be delta x for point M, and after that the next distance, this is the length of the perpendicular line. We can take it here from the model, or we can calculate these elements using the coordinates of the points. We always know the coordinates of the given points from the survey network, if they are from the cadastral map, or if they are certain line points from the detailed development plan, and we also know the coordinates of the new points that are from the model of the designed project. It is absolutely the same in case if the new point is at the other side of our initial direction. For example, we can have this point N. So to set out this point N, we need to firstly draw the perpendicular line. That is a perpendicular line to the initial direction. We need to measure the distance from the beginning to the end of the perpendicular. This is the first setting out element delta x, and after that the distance, the length of the perpendicular line is the next setting out element delta y. So this is the idea. For each point we need two distances, delta x and delta y. So here for point N we also need delta y. Each point two distances. It is absolutely necessary. So how to apply this idea in our setting out drawing for setting out the boundaries of our regulated landed property. Our property has 1, 2, 3, 4, 5 points from its shape, points of the boundaries. So we will set out these points to the directions from our setting for our certain line points. So we have one direction here between center line point 301 and center line point 611, and there is another initial direction that we can use, and this is the next direction between center line point 301 and center line point 302. Which of these directions we are going to use? Because the accuracy of setting out distances depends on the length of each distance, and here we are setting out two distances, delta x and delta y, it is better when we set out smaller distances. So all of the points that are closer to this direction we are going to set out to this direction, and the other points that are closer to the next direction we are going to set to the next direction. Usually when we have a property that has face to two streets, the setting out is made from the both of the streets. So firstly I'm going to start working to this direction. This is my starting point and this is my ending point. So firstly we need to draw these perpendicular lines. So I'm going to start with the first point, this point, and I'm going to draw a perpendicular line, polyline, to the initial direction. After that I'm going to do absolutely the same for the next point. This one here, perpendicular line to the initial direction between the center line points. For this point that is here, it's gonna be closer to the next initial direction, so we are going to set out to this line and to make all the labels to this line later. Usually in the drawings these lines they are arranged in a red color, and they must be drawn in with a dashed line. So maybe the scale factor for this dashed line here, I'm going to make it 0.5, suitable for the scale that we have. And I'm going to make all of the other perpendicular lines to look the same. So this is my first point. I need two distances for this point. The first distance is from the beginning, the initial direction, to the end of the perpendicular line. I'm going to measure it with circle. Here the length is 19 meters. If you are using a drawing on a paper, it is very easy to find what is the length of this delta x element, because it is going to be the width of the street, which was by your individual assignment A, plus the width of the adjacent sidewalk C, plus this one here, it was 10 meters, so you can calculate it or you can measure it from the drawing. It must be absolutely the same. So delta x for our first point is going to be 19 meters. Now it is very important how we are going to arrange the labels. There is a very specific instruction for arranging these labels when we talk about setting out points with orthogonal coordinates. Okay, I need one text element. This is a text element, so I'm going to take it. and I want this element to be with height 2 millimeters in the drawing for scale 1 to 500 in our case. It must be the label with height 0.8, or it also can be 1, it is absolutely the same. So this is 19 meters. We are writing not like this. We are always writing the values of the distances with accuracy till centimeter. So we are always writing these zeros if it is a 0. Okay, so this label, it is always orientated perpendicular to the initial direction. So this is my initial direction. The label must be written rotated in a perpendicular direction like this. This is the first thing. The next thing is the direction of this text. This text must be always with the direction as we are standing at the beginning, at the starting point when measuring the distance, and we can read this text. So writing this text like this, it means that from here we measure 19 meters. If the text is rotated the opposite way, for example like this, it means that the starting point, the 0, is at the other point. So from here to here we have 19 meters, which is not correct in this case. So always the orientation of the label is from the 0, from where we start measuring. Okay, so I'm going to correct it to look like this. Okay. So I have the first value, the coordinate difference is delta x. To set out these points at the end of our property, I need the second distance, which is the coordinate differences delta y in the local coordinate system, or this is the length of this perpendicular line. I can again measure it with a circle, 9.5 meters, or I can select the line and check what is the length of this line, or if I'm drawing manually on a paper, I can sum the width of the street plus the width of the adjacent sidewalk. In the assignment it was B plus D, I think, and again it must be absolutely the same value. So the label of this second setting out element, it is parallel to the line, and it is written again with the same direction, 9.5. But we remember that we always write the distances with accuracy till centimeters, so I'm going to add the 0 here, and I can move it a little bit in this direction just to be readable, not above the line. Okay, so I have this point, 2 setting out elements, I'm ready. Then the next point, again I need the distance from the beginning to the end of the perpendicular line. I'm going to measure it with circle. It is 44 meters. I'm going to copy this text and move it absolutely at the same place, and I'm going to change the value to 44 meters. Instead of measuring here in the model, you can calculate it how? We have this width, it is A plus C plus 10 meters here, and plus the length of this boundary, it was 25, I think, and again it must be absolutely, yes, 25 meters, absolutely the same value. Again, for setting out this second point, we need the other distance, which is the length of the perpendicular line, and because these lines are parallel, all the angles are perpendicular, and this is going to be absolutely the same. To check my drawing, I'm going to see, yes, it is absolutely the same, 9.5 meters. Okay, I have only 2 points to this initial direction, so I'm ready. But there is something for verification here that we need to write. In geodesy, verification is a very important element in all activities that we do. So we need to be absolutely sure when we go out on the field, on the street, that this point that is marked on the terrain and this point that is also marked on the terrain, they are absolutely the same points with the same coordinates as the points, the center line points in the detailed development plan. So we need to measure the distance between these 2 points, to measure it and to compare with the design distance between these 2 points. So again, we are here writing the distance between the reference points, the given points. In this case, the distance is 104.48 meters. And this distance must be absolutely the same when we go out and when we measure it in the field. This is for verification. This is the end of our initial direction. If we want to set out something from here at this side, we're going to use another 2 given points. So this is the last label here, and it is always underlined with 2 red lines. I'm going to draw one in a red color and I'm gonna offset it. The distance is the radius of this circle, for example, like this. Underlined label. This is where this is for verification between the given certain line points. Okay, now I'm ready with this direction. I'm going to make absolutely the same with these 2 points, but this is gonna be my initial direction in this case. I need to draw the perpendicular line from here, this point, to the initial direction. I'm going to make it look like all the other perpendicular lines. So I'm going to select this. Okay, and now absolutely the same. I need firstly the distance from the starting point to the end of the perpendicular. It is 19.5. I'm going to copy one text. The direction is perpendicular to the initial direction, so I'm gonna rotate this number, and it is orientated as we are starting from the starting point where is the 0, and we can read the label. So it was 19, not 9. Yes. And now the second setting out element, which is the length of this perpendicular line. In this case, this is 9 meters, so I'm gonna copy this label and I'm gonna move it here. 9 meters. I know that all of the lines are parallel, so I'm gonna copy this to the next point because it's gonna be absolutely the same. 9 meters. I'm checking this if this is correct. Yes, this is 9 meters. And I do not forget that for each point I need 2 distances, so I need to measure the distance from the certain line point to the end of the perpendicular line. This is 54.5 meters. I'm going to copy this text here. I made something else again. what was the distance? 54.5. Okay, I'm going to delete the circle, I do not need it anymore. And I'm gonna move the text like this. Again, we don't forget that we need to write for verification the distance between the two given points. So, measuring the distance. If you calculate the distance using the inverse geodetic problem using the coordinates of the point, it is going to be absolutely the same, 83.70 meters. And it is again underlined with two lines. I want this line to be with red color, and I'm gonna offset it. It keeps the radius from the previous one, so I'm going to use the same, like this. So what do we have now? When we go out on the street, we have this drawing. We can set out these 4 points, but this point here, for now I don't have the setting out elements. This point is approximately at equal distances from the first and from the second initial direction, so you can choose which direction to use, but only one direction. So for example, I'm going to choose to use this direction. If I draw a perpendicular line from this point, it's gonna be absolutely the same as this perpendicular line that I already have, so I'm going to delete it. And now I only need to write the both setting out elements. The first one is again from the starting point to the end of the perpendicular line, which is absolutely the same as this label that I already have, because the line is the same. But the next, the delta y coordinate differences here is going to be from the end of the perpendicular line to our point, which is 54.5 meters. So when we have more than one point that is placed on one perpendicular direction, all of the other points, excepting the first one, their labels are orientated in a perpendicular direction. So not like this. When we have more than one point, the label should be rotated like this. This is only when we have more than one point. So 54.5, and this circle I do not need it anymore. And because this is the last measured element, when we have more than one element, it should be drawn, underlined, like this with red color. Okay, now I have all of the setting out elements for all of the points from the regulated landed property. So this is what you need to do if you choose for the last point. If you choose to set it out not to this direction but to this one, we have this value here because the perpendicular line is going to be the same. And we only need to measure this distance, which is 44 meters. But because this is a second point to the same perpendicular direction, the value must be rotated perpendicularly to the perpendicular line. And this is 44 meters, again underlined. So very careful in this case we have label like this, and this means 44 meters in this direction. And in the first case we have label orientated or rotated like this, and this means 54.5 to this direction. So this is why the direction is very, very important, because if you look this drawing and if you measure 54 meters by mistake from here, 54.5, look where the point will go, and this is gonna be in the property of the next, it's gonna be in the neighbor, and this is gonna be a very, very big mistake. So careful with the orientation of the labels. I'm gonna go back to this first drawing to show you about the orientation of the text. I'm only gonna copy it. Okay, for example, for point P, I'm gonna delete these coordinates. I do not need them on when we make setting out with orthogonal coordinates as a drawing. So we thought that the first distance, delta x, for example, I'm gonna write a random number, for example, come on, 25 meters. It is always placed here, rotated in a direction perpendicular to the initial direction of the initial line, and the next element, delta y, it was placed like this here, parallel to the perpendicular line. For example, 7.54 meters. Okay, but if I have other points that is on the same direction, for example, point here, and it is P prime. The setting out elements for this second point, when they lay on the same perpendicular line, the first is the same, 25 meters, but the next label measuring it, for example, 34, no, doesn't matter. The next label, it is always written in this direction when we have more than one point. For example, it was 34 meters. If we have many other in this direction, the labels are gonna be orientated like this, and the last one, it should be underlined. When we have only one point, we have, for the first point, if it is only one or if there are others, the first text is orientated like this. It was absolutely the same as here on the example of our seminar 10. When you are ready with this, you can write the title of the drawing, the scale, absolutely necessary to have a scale on each drawing, and name your names. The colors, this drawing is always in color, because some of them are with red color, others with blue color, and all of the setting out elements, when we talk about boundaries of property, for regulated landed property, they are in red color. So this is what you need to prepare in your one drawing that you need to make for seminar 10.